Okay, now that we've worked with categorical data, we're going to go ahead and work with what we call quantitative data. So categorical data, we put them in categories. Sometimes the categories are numerically represented, but most of the time it's something like gender, so male, female, or favorite color, blue, green, something like that. This time we're going to do quantitative, so it's numerical, and this is numerical where it makes sense to average the data. So it does not make sense to average zip codes, it does not make sense to average phone numbers, but it does make sense to average age or weight or something like that. And so when we describe our quantitative data, we look at it in several different ways. We look at the center of our data. We look at relative location, also known as percentiles. We look at spread and extreme values, also known as outliers. So the first thing we're going to start with is measures of center. And measures of center are going to be known as, the first measure is mean, the next one's median, and the last one is mode. And so the mean is known as our average. To calculate the mean, we add up all the data values and divide by the number of values that we added together. And we try to remember this because it is really mean to make you calculate the mean without a calculator. Now the median is used when is found by when all the numbers are listed in numerical order, so from smallest to largest, and it is the middle number in the list, and that's called the median. Now if there are two middle values, so an even number of values, then we average the two in the middle, and that gives us our median. And then we have the mode, so the number or numbers that appear most often. So for our sample problem, students in Ms. Settle's class were asked, how many minutes do you spend working on homework last night? A random sample of 10 students resulted in the following data: 2, 60, 90, 0, 60, 10, 20, 60, 150, and 30. So the first thing we're going to do is we're going to go ahead and put these in order real quick. So 0, 2, let's see, 10, and then we've got a 20, and then a 30, and then 1, 2, 3 60s, and then a 90, and a 150. And I put them in order just because as we add them up and stuff like that, it's usually easier to add them up and do that all together. So for our mean, we're going to add them all up. So 0 plus 2 plus 10 plus so on and so forth. And then we're going to divide by the amount of numbers that we had. We should have 10 numbers because we took a random sample of 10 students. So we're going to add those all up, and what do we get? Let's see, 2 plus 10 plus 20 plus 30 plus 60, 60 and 60, and 90 and 150. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And so we get 482 divided by 10, which means that the students spent an average of 48.2 minutes on homework last night. Does that mean everyone spent that much? No. Obviously, we can look at the individual data points, but on average, when we average those out, that's what we get. And then we have median. So for our median, we're going to go ahead, and now that they're in order, we're going to find the middle number. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it looks like there's no number in the middle. So we take the two that are here. So we take the two that are in the middle, and we just average those two. So 30 plus 60 divided by 2 gives us 90 divided by 2, which is 45. So 45 is our middle number, or our typical amount of time spent on homework. And that's how we typically talk about that. And then our last one is mode, the one that appears most often. And since we have 3 60s, our mode is 60. And so again, all different values. One of them will be better than the others to use, and we can definitely tell mode probably isn't the best one because it seems so much different than the other two, but we'll talk about that more later. Okay, percentile locations. So if you're going to use the median as your measure of center, then your data is divided into a lower half and an upper half. So the lower 50% and the upper half 50%. So when you look at the first half, the lower half, you can find the median of that lower half, and that is called the median of the lower half is the first quartile. And what that means is that you end up with 25% of your data below that and 75% above. So it breaks it up into a quartile or a quarter of your data. So a quarter below and 73/4 above. Then for our third quartile, that's when we find the median of the upper half of the data. And this breaks the data up into 75% below and 25% above. So 3/4 below of that. That's why it's called third quartile for third quarter. And then everyone always asks me, what is your second quartile? Well, that's the median to begin with, because the median breaks it up into 50 and 50. So going back to our original problem, we had our data listed as 0 to 10, 20, 30, 360s, 1, 2, 3, 90, and 150. And so when we're looking at this, we've got our median, which we calculated the median to be 45. So the median was right here. So we don't include it because it's not actually any of our numbers. And then we go to our first quartile. So to calculate the first quartile, I'm going to look at this half, the lower half, and I'm going to find the middle value for that one. So I can find the middle value right here. So this is my first quartile. Which means 25% are on this side, 25% in between here and here. So I break it up into this 50% into 25 and 25%. So now I look on the other side and I'm looking for my middle value on this side. And so this is my third quartile. And so I'm looking at 25% in 25% here. So really, I have 25% above and 75% below. Or for my first quartile, I have 25% below and 75% above. And that's our quartiles. Now we're going to look at measures of variability, and this is also known as spread. How spread out is the data? And so we have different ways to measure spread, and our first method is range. So range is the difference between your lowest value and your highest value. We typically go highest minus lowest, highest minus lowest. Now, our next one is called interquartile range, also known as IQR for short. And for IQR, we look at the difference between the first quartile and the third quartile. So we do third quartile minus our first quartile, and that'll give us our IQR. And our last one is our standard deviation. And so for standard deviation, we average the distance of the values from the mean. Now we're not going to calculate that. We're going to save that for Algebra 2 when you guys have graphing calculators and stuff that's better equipped to calculate standard deviation, because it is a lot of calculation. But really it's just how far out, or what's the average distance from the mean. And usually we're always looking for less spread in our data. That's better than a lot of spread. So for our first problem, we're going to be looking at, again, students in Miss Settle's class were asked how many minutes did you spend working on homework last night. So for our range, we're going to do highest minus lowest. So highest minus lowest. So 150 minus 0 equals 150. And then for IQR, I have to go back and I have to figure out what was my third quartile. And then I'm going to subtract my first quartile from it. So I'm going to look back over here. My third quartile was 60. and my first quartile was 10. So what I'm going to do is I'm going to use those values, third quartile minus first quartile, to get my interquartile range, or IQR, which is 50. And so it's talking about just really how spread apart is my data. And so 50% of my data is going to be in that 50-point range. And the last thing we're going to talk about are extreme values. And our extreme values are known as outliers. Oops. Let's undo that. Oops. Outliers. Now, a value that is very different from the other values in the data set is called an outlier. An outlier could either be really small compared to all your other values or really big compared to all the other values. How do we calculate if something's an outlier? Well, we need to know several things. We need to know our quartiles, so that way we can calculate IQR. And then we're going to use our quartiles. So if I take my Q1 and subtract 1.5 times the IQR, that'll tell us the lowest value that is not an outlier. And then if I take Q3 and I add 1.5 IQR, that's going to tell me my biggest value. Anything outside of those two numbers, so inside of the two numbers is good. That's a normal amount of spread, but anything outside of that is going to be too extreme, and we call them an outlier. So, for example, our data, we have Q1 was, that was 10, right? Yeah, 10. And our Q3 was 60. So to figure out if there's any outliers, I'm going to have what we call a lower bound. It's kind of like our lower boundary, the lowest that it can possibly go before becoming an outlier. So lower bound, I'm going to take my Q1, and I'm going to minus 1.5 times the IQR. So what was our IQR? Well, if I subtract these values, 60 minus 10 gives me 50. So 10 minus 1.5 times 50, what is that, 75? This gives me negative 65. Are there any values lower than negative 65 in our list? No. So there are no outliers on the lower end. So the next thing we check is our upper bound. We're going to see if any numbers are too high. So I take my third quartile, 60, and I'm going to add 1.5 of my IQR. So I'm going to take 60 and I'm going to add that 75 to it. And when I do that, I'm going to get, I'm not sure, 60 plus 75, 135. And then I ask myself, are there any values higher than 135? And then of course we do. We have 150. So that means that 150 is an outlier. And so then we would ask them, hey, why does this one person have such an extreme value, 150? Did they accidentally put in 150 when they meant to enter in 15? Or is this just they're in a bunch of AP classes or honor classes and everyone else isn't, so that's the reason for that extreme value? Okay, the last part we're going to talk about is how to graph quantitative data. And today we're only going to do one graph, and that's called the modified box plot. And the modified box plot is going to have a box, and it deals with several different numbers. We're going to have to know our outliers. We're going to have to know our lower number, our higher number, all this sort of stuff. So I'm going to go ahead and down below, I'm going to 0 to 10, 20, 30, 360s, 90, and 150. I like having them in order so that we can really see how our list in order corresponds to our box plot. So our box plot, we're going to have to start at 0, and then we're going to have to go all the way up to 150 on the very bottom of our graph. So I can go by tens if I want. I don't know if I have enough room to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. Yeah, I have to go by tens. So 10. And when I'm labeling my graph, I'm putting numbers on here, but I have to think about what do these numbers really mean? Because I'm trying to represent this to the public who typically does not want to take time reading the whole question and all that. So we try and make it simple. We graph out our information and we say these are minutes on homework. Just really quick letting you know what this represents. And then what we're going to go ahead and do is we're going to go ahead and we're going to look for an outlier. So our outlier we decided already was 150. So I'm going to put a little dot there at 150, and I took care of that. Now I'm going to go ahead and I'm going to put a dot above the lowest value that is not an outlier. So my lowest value that's not an outlier was 0. And then I'm going to put a dot above my highest value that is not an outlier. So my highest value here is 90. Now I'm going to put a line that's going to be a side of my box, the first quartile. So remember our first quartile was 10, so I'm going to put a line at 10. And this is going to be one side of my box. And what I'm going to do is I'm now going to connect this dot to the side of the box. Now I'm going to put a line at the median, and I'm pretty sure our median was this 60. And so I'm going to put a line at 60, and I'm going to create part of a box. But that's only the middle of my box, or that's only part of it. I also have another line at my other third quartile. So let's see, let's just double check all of our information. So our median was 45. I forgot about that. Oh, got to fix that. So our median was right in here, so our median was 45, so I've got to fix that. See, it helps if all your information's on the same page so you don't have to recalculate. So I'm going to put a line at 45. So there's our median. And then there's our third quartile. So our third quartile is at 60. And then we draw a line here. So this is third quartile. This is our median. This is our first quartile. And then here's my lowest value that's not an outlier, our highest value that's not an outlier, and then here is my outlier. Some people like to put outliers as like little kind of asterisks or stars. You can do that. It's really up to you. And that's the box plot. So it kind of gives us a visual representation of how far spread out everything is, where our center is, where our percentiles are, and just really gives us a visual idea of what's happening. And that's what we're going to work on in class.